Welcome to another GCBASIC demonstration for the PIC16F legacy chip family. This applies to the 10Fs and the 12Fs if you generalize the approach. But I wanted to put a baseline set of tutorials and videos down with respect to the legacy chips, and this is part 19. Well, part 19 is the summary. We're done. You get a freebie in this one. So please like and subscribe, give it a thumbs up, watch the video all the way through. So we've seen how GCBASIC supports the high performance PIC16F. It does the same across the enhanced 18Fs, 12Fs, 10Fs, AVR, AVR-DX, LGTs. But this one, we've looked at digital analog, ADCs, various communication protocols, serial I2C, SPI, pulse width modulation, and you can go and get this PIC in many, many different chips, formats. So look, the videos, if you start with the end in mind, you go, we've made the board work, we made the LEDs flash, then we looked at the ADC, then we looked at time, then we looked at the inputs in terms of switches and how the master clear can be made as a reset switch or not, as the case may be. Then we brought it all together in what I call the LPC demo, which is the switch, the ADC, and the LEDs all flashing backwards and forwards in sequence and reverse. We then looked at serial, we looked at timers, timer 0, overflows, 16-bit timers. We looked at EEPROM. We moved into the communication protocols at video 11, discovery using I2C. I demonstrated I2C using GLCD device and then an SPI device using a GLCD. It's the same. To represent a target device. Looked at pulse width modulation in many, many different ways. External interrupts. We looked at program memory, EEPROM, and data blocks, how you can read them in with very simple commands. Then we looked at the overall tool change. In the last tutorial, looked at using MPLAB-X. Even for these old legacy chips, works fine. And now this summary. I hope you got a good idea that GCBASIC is a capable open source compiler for these microcontrollers, and it's supported the 16F for a very long time. And it's cross-platform with common code translation. We can take the same code from a PIC, put it into an AVR or an LGT. I'm going to show you some more common code translation in this video. We saw how the core compiler works. We saw how we can take source code. I'll bring my pen up. Take the source code, put it into a preprocessor, bring in the many hundreds of libraries that are available, goes through code translation into the assembler, which produces reports, which you can look at, and assembly files that you can look at through GCASM, the linker, and produces a machine-specific file. We also looked how the same process is adapted so that you can put this assembly file through an alternative tool to produce a hex file. And we looked at MPASM and PICs inside of MPLAB IDE for debugging. Fantastic. Very easy. But I'll show you some code translation for you. I'm going to show you a quick program going into the GC Code IDE. Pull up Control B, open up the Explorer, and open up Capability Demo. That's 400. Essentially the same header. It is the same header with one additional sound out. I found there's a sound chip on this, there's a sound pizza, so I've used that. And I've taken a program. And this program initializes the external 31K clock. And it does some stuff. Let's have a look what it does. You turn the There's the Labcam. There it is. It's there. Microchip, PIC19 Plus, GCBASIC. Oh, well, that makes sense, doesn't it? Yeah. And look, voltmeter. And as if I rotate the potentiometer, it says 0 to 5 on the LCD. Exit test, press function button here. I can go to the next test, which is S2, real-time clock. Do it now. And every second it clicks. How long do you think it took me to develop this program? It took me about 5 minutes. I'll explain why. I went into the demonstrations and picked up a previous demonstration for, I'll just turn this off because it's beeping in my ear. There we go. I went into a previous set of demonstrations for a similar board. I can't remember which one it was. I just picked up another one. Let me have a look in here. I went into vendor boards. I'll bring this in so you can see it. I went into vendor boards, picked M4, took this demo here, capability demo, and changed my chip. And all I had to do was change my timer. So Control B to get rid of that Explorer, Control J to get rid of the programming window. We'll get rid of those two. Fantastic. And it was the same program. How do you know it's the same program? The only thing I had to change was the switch names because I have a switch name. Oh, why did that? Oh, I didn't copy that bit across. I do apologize. It should be the same. Sure. There we go. Look. I'll just put it in. We'll try and look at this and see what the differences are. One on the right is from a completely different board. Oh, you can't see it on the screen because it's the way it formats. Is that working? Hey, that sort of works. I'm going to just make it a bit smaller. That's better. Voltmeter, real-time clock. Press some buttons. I got S2 where it was S1 on the other demo. Never mind. Buttons pressed. I added in the beep. So it goes beep. So that's the same here. Short tone. I added it on here. So it goes beep. Same switches. Voltmeter. Volts. ADC. Oh yeah, that was different, not? ADC con needed controlling on the 18F because it's got a very unusual ADC controller. That was the only thing I think I had to change. The rest of this, in reality, it took 5 minutes just to transmit it across. Okay, all right. Here we go. In it, the clock. Oh, I did change the clock. The clock initialization was different. I got 89 on this clock. On this clock, I got 15. I had to go to the data sheet, have a quick look to see how the clock was initialized. Show clock, it's all the same. The point is, portable code. With portable code, you can create solutions like that that work easily. Go back to PowerPoint, just shut that up. Thank you. All these tutorials are available up on GitHub, vendor boards, PICDEM2, plus board 2010. That's the actual board, is it? It is. If we look at desk cam, that's that there, 2010. That's how I've identified it. Tutorial presentations are also up there so that you can have a wade through it on your own. And I hope I've shown you that the PIC16F really does support the legacy 16F microcontrollers with a load of capabilities. And we support 32-bit operating system and 64-bit operating system, and it integrates with MPLAB-X. I hope you enjoy that.